So we've touched on it before, but I just wanted to make sure that we have a good understanding of what makes an isotope unstable. So within our nucleus, there are a couple of types of forces at play here. We have an electrostatic repulsion between the protons within our nucleus. So the nucleus are all positively charged and they are repelling against each other because like charges repel. But we also have mass attractions between all the particles, whether they're positive or neutral. So when we even have no neutrons in that nucleus, it's still unstable because of that great electrostatic repulsion of that nucleus there between the protons, and it makes for an unstable nucleus. But then just that mass attraction, so positive or neutral, they both have mass, so they need to be in a reasonable balance for the nucleus to be stable. So it's the balance of these forces that actually keeps our nucleus intact. So if we've got a really big nucleus, and we consider that anything above 80, there's too many particles in that nucleus for the mass attractive forces, so the mass pulling the particles, I suppose, together to overcome the other electrostatic forces, so the number of protons. There's too many there, so it's unable to overcome that, and so the nucleus then becomes unstable. So all our elements over 83 are unstable elements, although there are some under 80 that can have isotopes that are unstable. So for our lighter nucleus, the balance between those forces depend again still on that ratio. So for our elements 20 and under, we do have what we call that zone or band of stability that I showed you in the previous one, where we're really wanting our neutrons to protons to be a 1-to-1 ratio. So if I actually have, as you will do in the build an atom simulation, if you put 6 protons in for carbon 6 but no neutrons, that nucleus is also unstable. So even though it's a small nucleus, it's still going to have that 1-to-1 balance. So we tend to have about 6 neutrons in there as well. Then for our elements greater than 20, we do have a little bit more leeway. It's a ratio of about 1 to 1.5. If it falls out of this range, it's considered to be unstable. If the ratio is too low, so not enough neutrons, it usually is an alpha emitter. And if the ratio is too high, it will be a beta emitter. So many of these will occur naturally. So carbon can come in the form of carbon 12, 13 or 14. Hydrogen 1, 2 or 3 all form naturally. So does uranium and radium. But others are actually made by humans in nuclear reactors, and then that is where we have certain substances placed in a nuclear reactor, and they bombard the nucleus of a stable element, and they bombard it with your other particles in particle accelerators, and that will then make some of those other radioactive isotopes. So you're going to do a research task for me looking at some radioactive isotopes used in industry and also in medicine, and one of the ones that you'll see below is technetium-99, produced here in Australia at ANSTO for medical uses. We also have other radioisotopes used in irradiating food to make them last for long periods of time. So you will research that a little bit more in class. See you then.